Hello everyone, today we'll be studying IGCSE chemistry, a chapter called atoms combining. Now this is in most of the textbooks of IGCSE. This chapter is second chapter, and mostly in 9th grade of IGCSE they start states of matter, and after that they start this. So we'll be studying this. Okay, let's go into it. Atoms. First of all, we should know what are atoms. So you know, anything that you see in your surrounding, or whatever you're holding right now, your phone, everything is basically made up of very small particles called atoms, right? Now we are going to talk about this atom in detail. Okay, you must have seen, for example, if you have seen people around you, you might have seen some people who are very, peaceful at their own. They don't need any company to be peaceful, while there are some people who always constantly need some other person to be happy. So there are two kind of people, right? People who are already happy at themselves, with themselves, and there are people who need some other people to be happy, right? In the same way, when we talk about atoms, there are two types of atom. The one which are already stable, they don't need any other atom to be stable, and there are atoms which need some other atoms to be stable. Okay, so basically there are two types of atoms. One which are already stable, and the other ones which are like us, unstable. Okay, a stable atom and unstable atom. Let's talk about stable atom first. Okay, let's say I have neon. Now you must have learned in class 8 that the number of protons and electrons in neon, that is atomic number, is 10. So it has 10 protons and electrons. So if I write the electronic configuration, it will look like something like this. Now if you see, it has 8 electrons in its last shell, so it's stable. I'll take another example. For example, if I have argon, whose atomic number is 18, so what will be the electronic configuration? 2, 8, 8. Now if you see, this also has 8 electrons in the last shell. This is also stable. Now you should understand, the atoms which are stable, they will never bond. So these atoms will never bond. For example, I'll give you another example, helium. Now the atomic number of helium is 2, so the electronic configuration will be 2, right? Now it has 2 electrons in the last shell. You must have learned that if it's first shell, it should have 2 electrons, right, to be stable. So here its duplet is complete, and in these cases their octates are complete. So if an atom has complete duplet or octet, they are stable. And in this chapter we won't talk about these atoms. Why? Because these are already stable. We are going to talk about atoms combining. So those atoms will only combine which are unstable. Let's talk about unstable atoms. So let's say I have sodium. Now the atomic number of sodium is 11, so the electronic configuration will be 2, 8, 1. Now if you see, it has 1 electron in the last shell, which is not equal to 8, right? So this is unstable. So this has to bond. Okay, one more example. Let's say I have lithium. The electronic configuration, the atomic number is 3, so the electronic configuration will be this. Now this has 1 electron in the last shell, again unstable. Another example, oxygen. The atomic number is 8, 2, 6, again not 8 electrons in the last shell. This is also unstable. So when you have unstable atoms, those atoms will only bond, or we say will combine. So in this chapter we are just gonna talk about unstable atoms. First thing, that this is what you should understand. Fine. Next thing is, now so you have to say bye to these atoms, because we're gonna not talk about these atoms. Okay. Now let's say I have an unstable atom. Let's say I have an unstable atom unstable atom. What will that unstable atom do? It will try to become stable. Now it can become stable by bonding. Okay, so there are three ways in which it can bond. There are three ways in which it can bond. First is ionic bonding. Second is covalent bonding. And the last one is metallic bonding. So these are the three ways in which an unstable atom can become stable. Okay, and these are the things that we have to learn in this chapter. Okay, so let's start with ionic bonding. We will do covalent and metallic later, and these are the only things, again these are the only bonds or concepts that we have to study. Okay, let's start with ionic bonding. Okay, now please understand. Okay, let's say I have an atom sodium. Fine. Now the electronic configuration of sodium is 281. How many protons it has? It has 11 proton, because atomic number Z means atomic number, okay, is 11. This is the number of proton. And electrons are also 11. Okay. Now let's say it wants to become stable. Now to become stable, it has to complete its octet. Now if you see the last shell, it has 1 electron, so it needs 7 more to complete, right? So it can either take 7 from some other atom, but it can also lose this 1 electron. Why? If it loses this 1 electron, the last shell won't be this, the last shell will be this, because the last shell is the one which has electron. So if it goes, this electron goes, the shell will also not exist, because there won't be any electron in that shell. So there will be only 2 electrons, 2 shells. Okay. So let's say it loses this electron, so it will become Na. Now let's see what will happen. Okay, what will be the electronic configuration now? Now the electronic configuration will become 28, right? Now let us again count the number of protons and electrons. It has lost this 1 electron. Now the proton will still be 11, because it's not losing the proton, it's losing electron, right? So proton will still be 11, but the electron will be 10, because 1 electron is lost. Now let's see. We know that protons carry positive charge, so 11 protons means 11 positive, 11 electron means 11 negative. So plus minus 11 will be 0. That's why there is no charge here. If you see on Na, there is no charge. But if you see here, now there is 1 extra proton, basically 1 less electron is there, right? For example, here it will be plus 11 and minus 10. So if you do this math, we'll get plus 1, right? Therefore there will be plus 1 charge. And this is something which is called as ion. Okay, so first of all, for ionic bonding, you should understand the formation of ion. I'll give you another example. Let's say I have chlorine. Okay, the electronic configuration of chlorine will, its atomic number is 17. Okay, so the electronic configuration will be 287. Now again it will have 17 proton, 17 electron. So total charge will be 0, because plus 17 minus 17 0. Now to become stable, it can either lose this 7 or take 1. Whichever is easy, that will happen. Okay, whichever number is smaller, that will happen. So it will, instead of giving 7 electron, it will take that one. For example, the electron lost by sodium will be taken by this. So what will happen? Chlorine will become 288. Now let's see the electronic let's see the protons now. Protons will still be 17. Why? Because it's not taking proton, it's taking electrons. So protons never change. It will be 17. But electrons will become what? Can you guess? It was 17 here. Now it has taken 1 extra electron. So the electrons will become, very good, 18. So now there is 1 extra electron as compared to protons. So 17 protons will cancel 17 electron, but 1 electron will still be there, which won't get cancelled, and that's why it will have 1 negative charge, right? Now understand, this is also an ion. Okay, so first of all, you should understand how atoms become ion and how they get charges. Okay, these charges that I have written. Once you understand this, now see, Tell me, before transfer of electron, this sodium has no charge, right? Even this chlorine had no charge. So since they had no charges, there was no attraction. But now, if you see, this Na has become Na plus, and this Cl has become Cl minus, and now they'll attract each other. Why? Because in nature, we have learned if there are opposite charges, they attract each other. So these ions will attract each other. See, before they were not attracting because there was no charge, but now there is development of charges. So they'll attract each other, and this attraction is what called as ionic bonding. Ionic bonding between ions, not between atoms. Ions will only attract each other, atoms won't, because there is no charges on the atoms. Make sense? Very good. Next, now you should understand, when you take Na and Cl, of course you won't be taking one atom, you'll be taking multiple atoms. So there will be many Na plus and many Cl minus, okay, and they'll be arranged somewhat like this. One Na plus will be surrounded by 6 Cl minus. I have drawn from 4 here. One will be on the top of the whiteboard, on the top of in this plane, and the last one will be behind this whiteboard. Okay. Now, this you have understood, but we should also understand this using the electronic structures. Now you must be knowing what are electronic structures. Electronic structures are basically when you draw the atoms. I'll just draw the atoms, okay? Let's say I have sodium. This is sodium atom, so I'm drawing this. So one shell. This is, let's say, this is sodium nucleus. First shell, second shell, third shell. How many electrons? In the first shell 2 electrons, then 8 electrons, and then 1, right? Now I'm drawing chlorine here. Chlorine nucleus, first shell, second, third, fourth, okay? Now let's complete the electrons. We'll be using crosses here. 1, 2, 3, 4, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and 7 in the last shell. 2, 3, 4, 5, 6, 7, right? Now what will happen? This one electron from sodium will be given to chlorine. So now what will happen? Now I'm just drawing the last shell, outer shell, okay, the last shell. Sodium in now the last shell of sodium won't be this, it will be this, because this shell won't have this electron, so the shell will also not exist. So last shell will have 8 now, right? 1, 2, 3, 4, 5, 6, 7, 8, okay? And it will develop a charge, a positive charge. See? And chlorine will also have 8 electrons in the last shell, in the third shell basically. 2, 3, 4, 5, 6. You should understand one thing. 7, and the last electron that I'm gonna draw will be using dot. Why? Because this has come from sodium, and for sodium we were using dots, right? I'll have negative charge. Now these will attract each other, and this attraction is called ionic bonding. Make sense? Now there is another term for this bonding, this force of attraction. This force of attraction is also called electrostatic force of attraction. Why electrostatic? Electro means charges, so these are charges, and static means at rest, these are at rest, right? So electrostatic force of attraction. This is what ionic bonding is, and the compound formed here, which is NaCl, is called ionic compound. So I hope you could understand bit about bonding. So what did we learn today? We learned about stable and unstable atoms. Stable atoms are those which have complete octet or duplet. We won't talk about those atoms in this chapter. And unstable atoms are those which have incomplete octet or duplet, and those atoms will only bond. Now these atoms can bond in 3 ways: ionic, covalent, and metallic. We started with ionic bonding, and I think you could understand ionic bonding a bit, right? In the next class we'll try to do the properties of ionic compounds. Thank you.